Greetings to you all, my dear students. Now I am going to give you the descriptions for Kruskal algorithm. Kruskal algorithm is one of the classic greedy algorithm used to find the minimum spanning tree of a connected, weighted, undirected graph starting from an arbitrary vertex and repeatedly adding the minimum cost edge that connects a vertex in the tree to a vertex outside of it. So the main purpose of Kruskal algorithm is to find the minimum spanning tree. Okay, so now let me take the pen. Yes. So minimum spanning tree, MST, of a connected, that graph should be connected, that graph should have the weight and it must be an undirected graph. So we are going to start from an index, any arbitrary vertex which has the lowest cost, and repeatedly adding the minimum cost edges that connects a vertex in the tree to a vertex outside of it. And we must know what is a graph. Graph is a fundamental concept used to model relationships between objects. A graph consists of vertices, that means nodes, and edges, that is connections, representing the entities and their relationships. So here the main aim of the Kruskal algorithm is to find the spanning tree. So what is a spanning tree? A spanning tree of a connected, undirected graph is a tree that includes all the vertices of the original graph without forming any cycles, and it has exactly n-1 edges, where n is the number of vertices. Suppose if you have a graph like 1, there are 3 nodes here. Okay, so in this graph there are 3 nodes connected together, and here the spanning tree means a subtree of this graph, okay, which contains all the nodes, and n-1 edges. So now there is a link between 1 and 3 and 2 and 3, that's it. So this is a spanning tree. So here there are 3 edges. In this graph there are 3 edges. In this graph there are only 2 edges, that is n-1, n is the number of vertices and number -1. So that is the total number of edges in the spanning tree. So this spanning tree of this graph, contains only 2 edges. Suppose if you have 10 nodes or 10 vertices, then the corresponding spanning tree must contain only 9 edges, that is n-1 edges. Okay, so now you know what is a spanning tree. Now minimum spanning tree. What is minimum spanning tree? A spanning tree which has the minimum possible total edge weight among all possible spanning trees. So a tree can have many number of spanning tree, out of which we have to choose the minimum spanning tree. So the total cost of the tree must be minimum among all the other trees. So what are the applications of this minimum spanning tree? Why do we study this minimum spanning tree? So this is used in network design, clustering, approximation algorithms, then image segmentation. Network design, we are going to minimize the cost in laying cables, pipelines or roads. Clustering, removing the heaviest edges to form clusters. And in approximation algorithm, it is used for solving NP-hard problems like the traveling salesman problem. And image segmentation, this minimum spanning tree represent the regions in images hierarchically. So let us consider the graph. So this graph is represented, okay, mathematically G, okay, is a set of V, E. V means number of vertices. Here it is a set of vertices 1, 2, 3, etc. 7. There are 7 vertices, and E means edges. So edges here, there is an edge between the nodes 1 and 2, 1 comma 2 and 2 comma 3. Then 4 comma 6, 4 comma 1, so etc. So these are the set of edges, and V is the set of vertices. So now we are going to find the G dash. G dash means the spanning tree. G dash is also going to have all the vertices, the edges also it will have, but the number of edges n minus 1. That is, n means vertices, the total number of vertices minus 1. Okay, V dash, E dash. So V dash is nothing but total number of vertices minus 1. That is the edge. Okay. So this is a graph, and this is a labeled graph or weighted graph which has 7 nodes. In the 7 nodes, the edge between 1 and 2, it has the cost 10, 2 to 3, 28, 3 to 7, 16. Okay. So these are the cost. So we have to find the minimum spanning tree of the minimum cost. And next, the implementation of how do we find the minimum cost for this tree. Okay, so actually there are 2 algorithms, Prim's and Kruskal algorithm. So in this video, Kruskal algorithm is explained. So there are 3 main steps. We have to sort all the edges from low weight to high weight. So there are total number of edges. How many edges are there here? 1, we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 edges. How many edges? 9 edges. So 9 edges you have to sort in the ascending order. So first 1 comma 2, next 1 comma 4, ascending order 1 comma 2, then the next one is 6 comma 7, and after that 3 comma 5, then the next one is 3 comma 7. Okay, the next one is 22, 4 comma 6, then 4 comma 5, then 1 comma 4, the last one is 2 comma 3. That's it. So you have to find or you have to sort the edges. Yes. The next step is take the edge with the lowest weight and use it to connect to the vertices of the graph. First you have to find the lowest weight edge, then you select that, then after that the next lowest weight, and so on. If you add a new edge to an existing tree or an existing MST, then if it creates a cycle, then you have to reject the edge and go for the next least weight edge. And step 3 is keep adding edges until all the vertices are connected and a minimum spanning tree is obtained. Okay. So next consider the same example here. Now I am going to solve this. So here 1 and 2. So based on the weight allotted for each edge, you have to select. So first one is, which one is the minimum? 1 to 2. Okay, among all the weights 10, 28, 14, 25, 24, etc. So you have to select this edge. So here I am going to draw this. So weight is 10. So you are selecting this. A, select this. And next, the next least edge is 12. Paranga 6 to 7. So select this edge which is 6 to 7. 6 to 7. This is 12. Of course, here I can write the cost and also the number. So, first we select the edge 1 to 2. The cost is 10. அடுத்தது we select 6 to 7. So, that cost is 12 plus 12. And next we have to select the least one is 14. That is 3 to 5. 3 to 5, 14. Okay. 14. We are selecting this. So, 3 to 5, which is 14. And next we have to select after this 14, the next list is 3 to 7. So, 3 to 7, that is 16. So, 3 to 7, the cost is 16. Next we have to select after this 16, the least one, the next minimum is 22. So, if 4 to 6, yes, 4 to 6. So, 4 to 6 next. So, that cost, the edge cost is 22. And after this 22, the next one is 24. I am selecting, if I am selecting this 24, what it happens? It forms a cycle. See, 4 to 5, 5 to 3, 3 to 7, 7 to 6, then 6 to 4. So, it forms a cycle. So, you should not select this one. Okay. So, you have to, since it forms a loop, don't select this edge. So, after 24, the next minimum is 25. 25 here. 25. So, 25, what's the number? 1, 4 or 4, 1. So, the cost is 25. Okay, 25. This one. Okay, see, we have included all the items, I suppose. See, 1, 2 is included, 3 is included, 4, 5, 6, 7. We have included. And how many edges you have? 1, 2, 3, 4, 5, 6. We are supposed to have n minus 1 edges in this spanning tree. So, there are totally 7 minus 1, 6. So, 6 edges we have. And what is the minimum total cost? See here, if you add this, you will get 10, 22, 32, 36, 40, 50, 70, 72. You are supposed to have, see here, you should write, okay, let us 12, here 22, and here it is 25. So, if you add all this, you will get 99. 99 is the total minimum cost. So, this is how you should find the solution to form a minimum spanning tree. So, here how do we achieve this? How do we implement this, you know? So, by using the adjacency matrix, how you can write the algorithm. Now, theoretically, you know how to create or form a minimum spanning tree. So, now it is adjacency matrix. See, this is one of the representation of a graph. Okay, this is one of the representation. Adjacency matrix means this graph can be represented in the form of adjacency matrix. Matrix is a two-dimensional array. So, let us have here 1, 2, 3, 4, 5, 6, 7. And here the nodes 1, 2, 3, 4, 5, 6, 7. Then here you have to consider the cost and write it in this matrix form. So, 1 to 1. So, there should not be, okay, oh sorry. So, here it is not supposed to. So, let us take a very simple example to represent this adjacency matrix. So, here you have 1, 2, 3, 4. Okay, 4. There are 4. So, how to represent this graph in adjacency matrix? 1, 2, 3, 4. And here also you should have 1, 2, 3, 4. And 1 to 1. 1 to 1. there will not be no cost for 1 to 1. If it is, if you have an edge from 1 to 1, it will form a loop. Okay, you are not supposed to have a loop in a graph in order to find a minimum spanning tree. So let us put this infinity. And from 1 to 2, do you have any edge from 1 to 2? Okay, 1 to 2, yes, from 1 to 2 it is 10. So 1 to 2 you should write 10 here. 1 to 3, no. From 1 to 3 you don't have this cost, so 0. So 1 to 4, yes, you have 25. Something like, okay, so from 2 to 1, 2 to 1, 10. 2 to 2, infinity. 2 to 3, 28. 2 to 4, 2 to 4, no. So 0. Okay, so 3 to 1, 3 to 1, 0. 3 to 2, 28. 3 to 3, infinity. 3 to 4. Oh, I'm sorry. Oh, I'm sorry. So this is actually, I should write the weight for this graph. Instead of that, I have written the weight from this one. So let us take 10, 20, 30, 40. Okay, 10, 20, 30, 40. So 1 to 1 it is 10, infinity. 1 to 2, 20. 1 to 3, 0. 1 to 4, 10. 2 to 1, 20. 2 to 2, infinity. 2 to 3, 2 to 3, 30. 2 to 4, 0. 3 to 1, 3 to 1, 0. 3 to 2, 30. 3 to 3, infinity. 3 to 4, 40. And here 4 to 1, 4 to 1, 10. 4 to 2, 0. 4 to 3, 40. 4 to 4, infinity. So this is the graphical, that is the adjacency matrix of the graph. So we have to, when you do program, when you do algorithm, you have to read all these data and find the solution. The next one, so how the Kruskal algorithm. This is the Kruskal algorithm. Kruskal algorithm, we are getting the number of edges, then cost of the matrix, cost of the edges, then n the number, and t the final nodes of the minimum spanning tree. So input, here you have to give E set of edges of graph. Cost, it is a two-dimensional array which we have given in the previous slide. Okay, cost adjacency matrix, and this must be a positive value if edge I and j exist, and cost of I comma j is equal to infinity if no edge exist, and n the number of vertices, and next okay, of course this T is the minimum spanning tree. It is also a two-dimensional which contains only two elements in each row. One is the first edge and next one first vertex, and the next element is the next vertex. For example, if you have an edge like 1, 2, 2, 3, 3, 4. Okay, so something like, so this, it is a two dimension, so this is the first, second element, so on. And Kruskal algorithm, here we have to construct a heap. You would have studied this heap data structure. Construct a heap out of the edge cost using heapify. Heap in ascending order. Okay, we have to construct a heap in the ascending order. So this algorithm for I is equal to 1 to n, for I is equal to n to 1, do parent of I is equal to -1, because the first time when we select the lowest cost edge, you have to find u and v. Okay, so this will we used to find the Kruskal minimum spanning tree by using Kruskal method. So initially you have to assign -1 to all the nodes. Okay, parent of I is equal to -1 because each vertex is in a different set. When you have 7 vertices, you will be having 7 different set. Okay, then I is equal to 0 and initialize min cost is equal to 0. And while I is less than n minus 1, I is less than n minus 1. N minus 1. N minus 1 is number of edges. We should have n minus 1 edges in the MST. So this condition is there, and heap not empty. In this heap, what will be there? The edges will be arranged in an ascending order. So as long as there is an edge, you have to check whether it is the lowest or not. So for that, so delete minimum cost. Initially we will find the minimum cost edge u comma v from the heap and rehappify using the adjust. Then you have to find u comma v means which I and k, which j and k. These two are the other two methods to find u and v and assign to j and k. If j is not equal to k, then only we can move forward. Okay, if j is equal to k means it is a loop, so we are not supposed to find. So I is equal to I plus 1, t of I is equal, I1 is equal to u, t of I2 is equal to v. Then min cost is equal to, already you will be having min cost plus cost of u comma v, the new edge cost, it will be added. The previous slides I added no one by one, so something like. Then union, this is another procedure which is used to combine this j and k. That means u and v edge like 1 comma 2. So this will connect these two vertices 1 comma 2. And finally after this while loop, if I is less than n minus 1, then no spanning tree, right? No spanning tree, because you know, if there are no edges, then you cannot find the spanning tree. Else, if it is yes, then return min cost. So if you have 8 vertices, you have to form 7 edges to form a minimum spanning tree and finally return the min cost. Okay, this is the equivalent C program for the Kruskal algorithm. Okay, so that for Kruskal algorithm you have to read all the data and it will do. So this is the C program. You can compile this program and find out the answer. So here there is a sample output for this. So here consider this is the graph 1, 2, there are 3 and here the data are given. And when you execute that C program, you will get enter the number of vertices. Then you must enter 4. Enter cost adjacency matrix. Okay, cost adjacency matrix use 999 for no edge. If there is no edge, you have to type 9999 because that infinity is represented in 999. Okay, so 10, 10, 50. So these are the matrix value. Then edges in the minimum spanning tree will be 1, 2, 1, 3, 3, 4. So minimum cost is 40. For example, here I have to select this 1, 2 first. So 10. Then is there any 10? So from next one is 1 to 3. That is 10. And next minimum is 20, that is 3, 4, that's it, 3, 4, 20. So total is 40. So when you execute that one, so actually here instead of there is no edge, you have to put infinity. Yes, I made a mistake. So once again, so here 2 to 5 there is no edge. Okay, 2 to here 2 to 4, 2 to 4 there is no edge. So 2 to 4 you must put infinity. Similarly 4 to 2 infinity. Yes, if there is no edge you must write infinity. If there is an edge you have to write the cost. That's it. So when you execute the C program you will get the answer. Next problem, there are two problems given. You just work it out and find the answer. It will be very much useful to write your examination. So first problem, take this graph and find the minimum spanning tree and minimum cost. Okay. And next, here you just solve this problem. By seeing the graph itself, you can say, so minimum is 1, first you have to choose this one, and next minimum is 2, you have to choose this E2, D, and next one is 3, you have to choose this, then 3 to 4 you have to choose this, then 5, so already 5, okay, 8 to 5, already you have visited all the things, so just you find the MST for these two problems and find the answer. Hope you would have understood the Kruskal algorithm to find the minimum spanning tree. God bless you. All the best for your exam. Thank you.